Okay, so I'm just going to run through some vector basics. So first of all, let's just look at what a vector is. Okay, so a vector basically has magnitude and direction. That's all good, but the question is, what is magnitude? Now, magnitude is actually size. How big is it? What is its length? Okay, the direction is which way it is going. Okay, so let's look at a line segment that has direction. So let's put an arrow on it. Okay, so it has a particular size. And what we're going to do is I'm going to just like put a right angle triangle here. And let's just say this was 2 down and 3 across. We could also plant exactly the same vector, same direction, 3 across and 2 up. So it goes to the point 3, 2 onto a number plane with x and y. So that would be 2 this way and 3 along there. Okay, so when we're looking at this triangle here, okay, so when you're looking at that triangle there, first of all, if you wanted to get the length here, you just like using Pythagoras' theorem. X squared is 3 squared plus 2 squared. So x squared is 9 plus 4. X squared is 13. So basically, x would be the square root of 13, would be the length of that vector. So the length of the vector is called the magnitude. And if I called this vector, we call it vector A, then the way to symbolize the magnitude is to put 2 absolute value signs on it. So that just means the distance that this point here is away from that point there. So if A was equal to x I plus y j, then the magnitude of A would be equal to the square root of x squared plus y squared. Now, let's just say we call those 2 endpoints there, A and B, and we're just calling this vector A. Then that would be your magnitude. Now, what would the direction be? Okay, so with the direction, you always make it between minus pi and pi. So we'll call that theta. So theta is the angle that the vector makes with the horizontal. So by the horizontal, we basically mean like with that line there. Okay, so this vector here, there it is going out there. So we're talking about that angle there. That is an acute angle, and it is in quadrant 1. So when we're looking at that, and that's 2, 3, then to find what that angle theta is, you go tan theta is 2 on 3. So theta would be tan the minus 1 of 2 on 3. So as far as doing it for a general rule, say for this one here, then the magnitude of A, which is its direction, so the magnitude of A will equal the square root of x squared plus y squared, but the direction is just theta. That'll be theta equals tan the minus 1 of y on x. So do you notice when tan theta equals y on x, tan of that angle is actually the gradient, because the y on the x is like the rise on the run. Now things can go in all different types of directions, and they range from 0 through to 180, or 0 through to minus 180. So in this quadrant it's theta, in that one it's 180 minus theta, or pi minus theta. This one's minus theta, and this one's minus 180 minus theta. Okay, so when you've got a vector going in that direction, and let's just say that was 4 and 5, then basically, actually let's not make it 4 and 5, let's make it something really easy to actually find. We'll put that 4. the direction that's going in with the horizontal, if you turn that way, that would be a negative angle. So it's negative 180 minus theta. So we've just got to find out what theta is, and we put theta there. So tan theta equals 4 on 4, which is 1. So theta is tan the minus 1 of 1. So that means that theta equals 45, or pi on 4. So if you did pi minus pi on 4, or 180 minus 45, that's 135. This one here is times 4. 4 minus 1 is 3 pi on 4. Then that would be a negative answer. So the direction would be minus 3 pi on 4, or minus 135 degrees. Okay. If you planted that on a number line, just have a look where that sits. Like if you took that and you put something in the same direction, going down like that, okay, then that would be like your minus 180 minus theta, or in this case it was minus 135. So magnitude, size, direction can be this angle here, which is theta, that one there, which is obtuse, or 180 minus theta, this one here, which is minus theta, that one there, which is minus 180 minus theta. Now, there are 3 ways to write something as a vector. Okay, first of all we have a column vector. Now, a column vector is in the form of x, y. Okay, so for example, so you have minus 3, 4. What that first one there, that is your x. So that means go minus 3 in the x direction. 1, 2, 3. That's along there. And then the 4, well, the 4 means go up 4 because it's positive. So go up 1, 2, 3, 4. Okay, so that means that this would be the vector here, and it is going in that direction there. And if you planted that on a number plane, it's a lot easier to see again, because you can see it just goes like that. So that there, the y value is 4, the x value is 3. So if we went tan theta equals 4 on 3. So theta is tan the minus 1 of 4 on 3. So you get that angle for theta, and then you just go pi minus theta, and that there would be the angle that this vector makes with the horizontal. The same here, the angle it makes. So if you go shift tan 4 on 3, that's going to be 53 degrees. Now you could leave it in degrees, because I've got the pi in radians, I'm going to times by shift pi divided by 180. So I get 0.9 in radians. So it's 0.93 radians. So I could take that away from pi. Shift pi, and I end up with 5.4 radians. If I wanted it in degrees, it'd be 180 minus 53, which is 127 degrees. The magnitude of that vector would be the square root of 3 squared, square the minus plus 4 squared, which is root 25, which is 5. So the first one's a column vector. Then we could also do a component vector. So there's component form. Okay, that's where you write xi plus yj as your vector. So let's just say, for example, you have minus 2i minus 2 root 3j. Okay, so if we look at that, if we wanted the magnitude, minus 2 and minus 2 root 3, that would be in that quadrant there. So that's what we're talking there. So we're talking about a negative obtuse angle here, minus 180 minus theta. So we'll call this vector A. If I did the magnitude, it would be minus 2 squared plus minus 2 root 3 squared, which is 4 plus 4 times 3, which is root 16 or 4. That's your magnitude. Now, tan theta equals 2 root 3 on 2, which is root 3. I'm just getting the acute angle, therefore I'm not interested in the sine. So theta is tan the minus 1 of root 3, which is 60 degrees, or pi on 3. So therefore, if you did 180 minus 60, you get 120, or pi minus pi on 3, which is 2 pi on 3. So it's going to be minus 120 or minus 2 pi on 3 if you had it in radians, because basically it's coming along here. Okay, so we have, the first one I did was just an obtuse angle, and it turned from here. The last type is an ordered pair. So an ordered pair is just where you have like x, y, okay? So you could have 3 minus 2. So 3 minus 2 would be across 3 down to minus 2. That's there. Okay, tan theta equals 2 on 3. So the acute angle is tan the minus 1 of 2 on 3. And shift tan 2 on 3. You end up with 34 degrees. So that's just going to be minus 34 degrees. That's your direction. So it means you face with the horizontal and you turn minus 34 degrees. And the modulus is the square root of 3 squared plus 4 squared, which is root 13.